Hey there guys, welcome back to another video on my channel, and this is C memory management, and I have been trying to make this video from the past 1 hour because I'm making silly mistakes in explanations. So I'll try to make this perfect now. Anyways, what do we do till now is static memory management. So that means the compiler knows exactly how much memory it requires for a program. Okay, so the disadvantage of this is that you cannot change the memory on the runtime. So say for example you wanted to store roll number of 100 students, so you will quickly declare an array for 100 students. Okay, now good. Now for example, what if your need changes? Now you want to store 1000 number of roll numbers instead of 100. For that you will have to change your program and then give it back to the user, and so that he can store, instead of 100 he can store 1000 number of roll numbers. It's okay, sounds pretty easy, but if you're dealing with a big program, imagine you will have to change anywhere you manage these roll numbers for 100 of data. Now you will have to change that for thousands of data. So that's pretty much a big edit in your program if your program is pretty big. So, and then obviously you will have to edit, so user will have to reach out to you, just tell you that my needs are changed now and blah blah blah. So you will have to edit the program as per his needs. So that's pretty a big schedule. Anyways, let me just not get lost again in my explanations. So there is a way to make sure that you can input n items. Now pretty much you will be thinking that I can just scanf n number of items and input n over here instead of the size, so that the roll number become n number of items. But that's not the way it works. C will not allow you to do that, because I have over here I have done this thing. I have inputted number of items user wants in n, and I have tried to declare a array of size n. But this will not work, because when you are declaring an array, C or pretty much any language wants to know how much size you want to give to that array at the time of compilation. When I type gcc filename.c, at that time, not at that on the runtime .a.out, not at that time. So it needs to know when at the compile time how much memory the array needs. So or in this case, when I will run this, then I will enter the value of 9, and then it will know, okay, I need to, the n is equal to 20, so make array size 20. But since it needs to know the size of the array at the runtime, this will throw an error. Oh, sorry, at the compile time, this will throw an error. So you cannot do this. So you cannot change the program like that. And the other advantages of dynamic memory allocation is, say for example, you are done with these variables over here in your program. Okay. So what the dynamic memory allows you to is that you will free these variables, and you can now use the same memory to create new variables in your program, or altogether the operating system can take this memory back from you, and give it to another program requiring it. So that's the beauty of dynamic memory allocation. So anyways, let's just get to it. Dynamic memory allocation is done by using these three functions, and the free I just told you is done by this function. So the malloc right now over here is a memory allocation function. Okay, it returns a void star, which is a void pointer, which means the void pointer will just point to the address and not the value inside it, or not what type of the value you want to store. So it will just do that. And the size over here, you have to pass the number of bytes you want to give to the a pointer variable, because this is going to return a pointer, so we need to catch that in the pointer. So I have used this as I have shown you an example. I have declared a float pointer, and I have typecasted this void pointer, which will it return to me, to a float pointer, because I need the value now. I need to work with float, so I have to typecast it, and I have called my malloc function and said that give it a size of 1 float. So it will only work for one float. It will give the, say float takes 8 bytes, so it will give a block of memory of 8 bytes to this pointer A. Okay, and this A pointer over here will basically point to the first block of the memory you are giving it. So you will learn that over here. So say for example this. Okay, what I'm doing is I am calculating this calculating the memory required to store n number of integers. So size of integer will give me the size of number of bytes required by one integer, which say for example is 4 bytes, and if you multiply it by n, it will give you the size required to store n number of integers. And I have declared a pointer over here, and what this function will basically return me is the address of the first block. So this pointer will now point to the address of the first block of the memory it's giving me. So let me just quickly explain that to you diagrammatically. Say for example n is equal to 3. So the malloc function will give me a block of memory, this big memory, and inside this there will be 3 blocks. So it's giving me a memory which has 3 blocks. Okay, and the PTR will point to this. The PTR will point to the first block. If I do PTR plus 1, it will point to the second. PTR plus 2 will point to the third block. Okay, so as you can see, this is now an array. Okay, so if I write PTR plus 1, if I write this, if I write PTR plus 1, it's basically the second block. And if I write star PTR plus 1, it's giving me the value at the second block. Okay, so when I am typing like this, if you see the code below, I'm typing in square brackets. So what does this mean is when I'm typing PTR I or PTR say 0, this basically means value at PTR plus 0, which means the value at the first block. So that's why the array starts from 0 and not 1. So when I type PTR 1, I basically mean value at PTR plus 1 address. So this will give me the second block, and hence the PTR square brackets 1 or PTR 1 is the second block of the array and not the first. So similarly, PTR 2 will be basically value at PTR plus 2 and so on. Okay, and when I type address of PTR 0, that's basically means this, PTR 0. Or say, it basically means, when I type the address of PTR 0, it basically means the address of the value at PTR 0. So that's the same thing as PTR 0 or PTR. So that's the working of the malloc function. It will give me the address of the first block of the array in the PTR, and then I can manage my PTR as an array to use the values. So I'll just quickly run this and show that to you guys that it works. I'm gonna compile it and run it, and now it's asking me for the number of values I want to store. So I'm gonna store 5 values. So the first value I'm going to enter 1, the second value I'm going to enter 2, the third value 3, 4, 5. So now as you can see, I printed star PTR plus 0, or simply PTR 0 is equal to 1, star PTR plus 1, or simply PTR 1 is equal to 0. So star PTR plus 2, or simply PTR 2 is equal to 3, star PTR plus 3, or simply PTR 3 is equal to 4, star PTR plus 4, or simply PTR 4 is equal to 5. So this is the address of the first block, or the first block the malloc gave me. This is the second block the malloc gave me. This is the third block the malloc gave me. This is the fourth block the malloc gave me, and this is finally the fifth block the malloc gave me to store 5 values. If I want to store 3 values, it will only give me 3 blocks. So here we go. So this is the dynamic memory allocation in C. So now we work with the calloc function, and the calloc function differs in two ways. It will not take only the size, it will take this. So first we were typing the n star size. It says that you don't multiply, you just give me the number of items and size of one byte, and I will do that size of one data type or data item, and I will do the math myself to give it the number of bytes to store the number of data you want to. So to show you that this works, I'll first show you and tell you one more difference in calloc and malloc. Okay, so I'm storing 4 bytes. 1, 2, 3, 4. I'm storing 7 numbers now. 1, 2, 3, 4, 5, 6, 7. And voila. So the other way the malloc differs is, say for example, I cannot show you that because my operating system will not be helpful in that way. So let me just tell you this. Where's this? Yeah. So the way the malloc works is this. So this is right for three number of integers. Malloc gave me this. So say for example, I'm first asking the user that enter the total number of values you want to store. So say the user enter hundreds. Okay. So he will enter 100 number. So I will now have 100 number of blocks. Okay. And we'll just work with 3. So the user enters 3, right? But for some reason, user only stores 2 values and stops inputting and continues further. So this block will be empty. Okay? The way malloc works is this block will have some garbage value. Say for example, if you were storing integers, so this block will have some random value, say 1, 2, 3, 9, 7, some random integer value. So that's what malloc does. The way calloc works, if you ask for if you ask from calloc that you want to store 3 items, or say 3 integers, it will give you 3 blocks, and it will initialize them all to 0 automatically. So instead of having some garbage value for the third block which you didn't input, it will have a 0 over here. So that's the way the calloc works. And why I cannot show you this is because my operating system automatically assigns the unused memory blocks to 0. So that's why I cannot show you. I tried that before making this video, so I know. So anyways, that's how calloc works. And the way realloc works is, say for example now, after inputting, if you want to increase or decrease the size of your pointer, you use realloc. So I'm just gonna quickly do that for you guys. Control C, Control V. So now what's going to happen is I am now taking the number of items the user wants to insert now. So it may be that he might decrease the number of items and he might increase the number of items. So to increase or decrease the number of blocks associated to the pointer, we use the realloc function, or basically reallocate the memory. Realloc. Now it takes the n star will be returning over here, and the PDR will be returning over here. So what's this thing is, it takes the pointer to reallocate to, or basically the pointer which you want the memory to be reallocated, and the size you want to reallocate, or the new size you want to give it, and the what pointer will be pointing it to. So basically, why this pointer over here? So the way realloc works is, say like this. Where is this? Okay. So now I want to reallocate my PDR, and I only want it to point to I want it to store two integers. So the way the realloc will work, realloc will pick the block of memory pointed by this and will allocate to this. So it will pick my PDR block, so it will pick this, okay, it will pick this and reallocate to 2 blocks. So it will give me this block and this block, and this block will no more be assigned to whatever I'm equating to. So I'm equating that to PDR, so the third block will now not be assigned to PDR. Okay? So that's the thing. And the way the realloc works, if it can increase the if you are increasing the number of elements, it will take this PDR and see if it can actually assign more blocks to this. If it can, it will. If it cannot, it will try to get new set of blocks from 0 to the number of elements to try and reallocate the memory. And if you are decreasing the size of this PDR, what it will try is it will try decreasing this amount like we did over here. And if it can, well and good. If it cannot, it will just simply remove everything and then give the PDR new blocks, new 2 blocks. So that's what it does. So basically you need to remember that reallocate will reallocate your memory, and if it can, it will try to save the previous values. If it cannot, then it will have to delete all those previous values and reallocate the memory altogether. So that's what it works. And now I'm gonna take the inputs and print again. So I'm gonna save it and quickly there we go. Yeah, you're here. I'm just gonna clear it so you can see it on the top. Run it. So now it's asking me for the first time, so I enter 5 values. 1, 2, 3, 4, 5. It printed me. Now I am increasing the size. 10. Not 10, 7. 1, 2, 3, 4, 5, 6, 7. Okay? So it printed me the 7 values. Now instead of taking input, what I'm going to do is I'm just going to print after reallocation. Okay? So here we go. Clear. Compile again and run again. So I'm going to first assign it 6 values. 1, 2, 3, 4, 5, 6. And now I'm going to increase to 9. And as you can see, it stored my previous values. I entered 5 values, 1, 2, 3, 4, 5, 6. It stored my previous values and to them added 3 new blocks to make sure that the PDR now can point to 9. Can store now 9 different integer values. And this is the garbage value we were talking about. Finally it showed up, and this is the 0. So mostly my my operating system assigns zeros by default, so you are seeing zeros over here instead of a garbage value. So that's the way realloc works. And if I try to decrease, let's see what happens. 6 values again, 1, 2, 3, 4, 5, 6. Now if I try to decrease, I will keep only 3 values. So as you can see, it kept my previous 3 values. It kept my 3 values, but it discarded my 4, 5, 6. Okay, so that's how realloc works. Now, freeing. Freeing is a tricky thing. I'll not reallocate it. I will just free my PDR. So as I told you, free only tells the operating system that I don't need this memory. I don't need the memory associated to this pointer anymore. So if you want, you can take it. But it will not change the values. It will not make this pointer point to null. So I will show that. So I will now just quickly compile you, then show you how the free works. I'm just gonna quickly show you. I'm gonna store 5 values. 1, 2, 3, 4, 5. Okay. Now it's asking me to input the n again. So I'm just gonna input 5 only because we stored 5 values first. So now you can see the values differ. So but it still points to something. So PTR still will point to the memory block which it pointed to before after freeing. And why you see the 0, 0 over here is because when we freed it, my operating system decided to set the first block PTR pointing to 0 and the second block PTR pointing to 0, but it didn't. But it said that okay, my operating system said that I will assign the first two blocks the PTRs pointing to 0, but the other blocks the values remain intact because my operating system did not touch them. So this free basically is an operating system dependent function, but what it does is it basically tells your operating system that whatever this PTR is pointing to and the memory associated with the PTR is now free to use for you. So that's how free works. So this is the memory management. This is one hell of a long video, but this is very important. So make sure you get all the stuff I talked about in this thing. And if you don't get anything, just tell me. And if you want even more proper explanation, I can make videos for each of the functions. But I have pretty much explained each of the functions to you now. If you have any doubts, please leave it in the comment section below. And I will be happy to help you guys. Thanks for watching. Goodbye.